Hello there everyone, welcome to Edupedia World 9th Grade Computer Applications video lecture series. I'm Upeka Vandibona, and from this episode we are talking about the difference between method overriding and method overloading, specifically the rules in them. Let's take the first one, overriding, and you already know about it. When you override a method from a superclass, you are agreeing to fulfill a contract. A contract that says, for example, I take no argument and I return a boolean. In other words, the arguments and return types of your overriding method must look to the outside world exactly like the overridden method in the superclass. Now in this example, we have two classes, appliance and toaster. Now tell me, what is the relationship between these two classes? Let's take a is-a test and a has-a test. There is no sense of saying appliance has a toaster or toaster has an appliance. Therefore, has-a test is not working in here. Therefore, let's take a is-a test. Now, appliance is a toaster doesn't make sense either, but toaster is appliance. It works out. That means toaster is a subclass of appliance and appliance is a superclass of the toaster. Therefore, when we declare the toaster class, we say toaster extends appliance. Now this appliance class has two methods, turn on and turn off, and both of them returns boolean values. Now this toaster class, it has a method with the same name as turn on, and also it will returns a boolean value. Inside the parenthesis, it takes a int type parameter, but in the appliance class, the turn on method doesn't take any parameter. Let's see whether this scenario is an overriding situation. If polymorphism is going to work, the toaster version of the overridden method from appliance has to work at runtime. And remember, the compiler looks at the reference type to decide whether you can call a particular method on that reference. With an appliance reference to a toaster, the compiler cares only if class appliance has the method you are invoking on the appliance reference. But at the runtime, the Java virtual machine looks not at the reference type, the appliance, but at the actual toaster object on the heap. So if the compiler has already approved the method call, the only way it can work is if the overriding method has the same arguments and return types. I'll repeat that part. The overriding method has the same arguments and return types. Therefore, what's in the toaster class is not an overriding method. Otherwise, someone with an appliance reference will call the turn on method without any argument, even though there is a version in a toaster that takes an argument. So what's in this example is not a overriding method but a overloading method. We will talk about what is overloading later in this episode. We first define our first rule in overriding. Arguments must be the same and return types must be compatible. The contract of superclass defines how other code can use a method. Whatever the argument superclass takes, the subclass overriding the method must use the same argument. And whatever the superclass declares as a return type, the overriding method must declare either the same type or a subclass type. Remember, a subclass object is guaranteed to be able to do anything its superclass declares. So it is safe to return a subclass where the superclass is expected. The second rule is the method can't be less accessible. That means the access level must be the same or friendlier. Now take a look at the example. In the appliance class, both the methods got public access modifiers. But in the toaster class, it got a method with the same name turn on, with the same return type boolean, and without taking any parameters like as in the superclass method turn on, but with different access modifier private. So it is trying to override, but we can't override the public method and make it private. So what's in this example is not a legal override because you restricted the access level, and also it is not a legal overload because you didn't change the arguments. So this is not a legal source code totally. Good. Now we are talking about overloading. Method overloading is nothing more than having two methods with the same name but different arguments list. In other words, an overloaded method is just a different method that happens to have the same method name. It has nothing to do with inheritance and polymorphism. An overloaded method is not the same as overriding method, because in overriding method it has something to do with inheritance and polymorphism. But for overloading method, it has nothing to do with inheritance or polymorphism. I'll explain it like this. Overloading lets you to make multiple versions of a method with different argument lists for convenience to the callers. For example, if you have a method that takes only an int, the calling code has to convert, say, a double into an int before calling your method. But if you overloaded the method with another version that takes a double rather than int, then you have made things easier for the caller. Since an overloading method isn't trying to fulfill the polymorphism contract defined by its superclass, the overloaded method have much more flexibility. Now let's define our rules in overloading. The first rule is the return types can be different. You are free to change the return types in overloading methods as long as the argument lists are different. The second rule is you can't change only the return type. If only the return type is different, it's not a valid overload. The compiler will assume you are trying to override the method, and even that won't be legal unless the return type is a subtype of the return type declared in the superclass. To overload a method, you must change the argument list, although you can change the return type to anything. The third rule is you can vary the access levels in any direction. You are free to overload a method with a method that's more restrictive. It doesn't matter since the new method isn't obligated to fulfill the contract of the overloaded method. Now take a look at this example class overloads. It got an instance variable unique ID, which is a string type variable, and it got 4 methods. 2 methods with the name addNums and 2 methods with the name setUniqueID. We first consider the methods which got the same name addNums. Both of them got the same access modifiers, public, but different return types. One got int return type and other one got double return type. When talking about the parameters, one method get int type arguments and the other method get double type arguments. Inside the body in the both of the method, it does the same thing. Add up the parameters and return. And that's why the return types are different in both of these methods. When we add up int type values, we will get the result as a int type value. When we add up the double type values, we will get the result as double type value. When we call the addNums method by passing int type values, the first method will be called up. But when we call the addNums method by passing double type values, the second method will be called up. So this is a legal overloading situation. Now take a look at the third method and the fourth method. The same name setUniqueID, the same access modifier public, same return type void, but different parameters. When we call the setUniqueID by passing a int type value as the argument, the fourth method will be called up. And then this int value is converted into a string value. You can see there the SS number is assigned into a string type variable. And then again the setUniqueID method is called, and this time the argument is become the local string type variable. And that will call up the third method which takes up the string type arguments. This method is the original standard method because a lot of validation stuff is happening in there, and also a value is assigned to the instance variable unique ID. So this third method is the method that will do the work, and fourth method is a supportive method that will arrange the argument suitable for the third method. And that's all what we got here in this episode. Hope you got a good understanding about the difference between overloading and overriding. From the next lecture, we are talking about another important object orientation concept, abstraction. Thank you for watching and see you in the next lecture. This video brought to you by edupediaworld.com. Watch more from our website.